Previously, we had spoken about JavaScript objects and how JavaScript objects can be created within our applications. They can be created using the JavaScript literal notation, which I have highlighted right here on our screen. And then we could also dynamically add values to our JavaScript objects in order to create more robust objects, which pretty much just hold data in our applications. Focusing on that aspect of JavaScript objects, that they are data structures and can be used to hold data, one really cool thing that has happened over the last decade is that we have transitioned from XML as the data transmission format that we send across the web. And we're not going to get deep into XML. Just know that it's a verbose, very complex, sometimes very frustrating data format that requires a lot of extra information just to transmit data across the internet. Now, it definitely has its uses, and times and places for it are definitely necessary when we have highly structured data that needs to be validated. But when we are passing simple data over the internet, what has happened over the last 10 years is that with the increase of frameworks that run inside of a user's browser, and being that all of those frameworks are written in JavaScript, it kind of took off that we began to use JavaScript objects as the data structures that we pass across the internet when somebody asks for information from a web application, web API, or a web service, whether it be their own or whether it be somebody else's. And with that, what came about is what we call JSON, or JavaScript Object Notation. So it looks like that. You'll see JSON, and really it just stands for JavaScript Object Notation. And really in JSON, all we're doing is we are using the notation that we have right here, the curly braces with the key value pair syntax, in order to format plain data in that text file or text format that we send across the internet. Now, when somebody receives data back in JSON format, which means a file that either has the .json format or through a web service or web API that specifies that the data that they return is going to be in JSON format, what we can expect as a developer is plain text that follows the format that JSON objects have when we or JavaScript objects have when we create those objects in JavaScript. Now, the difference between what we have right here, where we have a variable name that references the object, this has a reference because we are actively inside of JavaScript, and JavaScript needs a way to reference this object. So you have a variable right here that we assign the object to. Well, when we get JSON data back, we're getting just this part, just the object. And we get it back in plain text, and that plain text is formatted and follows this particular format. What that means is that inside of JSON data that we send or receive across the internet, or that we pull from disk or from the hard drive, that is in JSON format with a .json extension, is we expect that there be a root object that everything is wrapped inside of, just like we do right here. We have this root object which begins with these curly braces. So in a JSON file, or when we get JSON data, we should see a root object right here, and inside of this object is where we're going to have all of our data. So if we were to get this particular object sent to us across the internet, it would look something like this. Right? Now, to make sure that this is in proper JSON format, we need to make sure that all properties and values are formatted inside of double quotes. So let's go ahead and fix that really quick so that it's not yelling at us. We want that in double quotes. So let's get rid of our single quotes here that are causing us problems. All right, so all keys and all values need to be in double quotes just to follow the proper JSON standard. So a little bit different than this, because in JavaScript, these are really variable names, and variable names we don't wrap in quotes. And so these properties are actual variables, as we went through in our last discussion. So they're not in quotes. Only the values are in quotes when they're string values. But here, we're going to go ahead and to follow JSON format, all property names also need to be in the form of a string. Now, that doesn't mean that we can only provide string values. We can provide integer values as well. So let's say that we've got age right here. We can also provide, 21 as a valid value. So we can pass strings and we can pass numbers. And we can also pass decimals as well as numbers. So we've got age. What can we do that's in a decimal? We can do height. We can do height again. And then we can just go ahead and say, oh, I have no idea what my height would be in metric. So let's just go ahead and put something in there. Maybe I'm 72.5 centimeters. I have no idea. It goes to show you that I'm stuck on the imperial units. All right, so 72.5. I have no idea what that really is, and I'm not going to bother looking it up. But you can see that you can also pass a decimal. So here we've got these different data structures where we are using just simple data types, strings and numbers. We can also pass data structures inside of our JSON. So let's say that we also wanted to provide a list of things that are a part of this data that belongs to Tim Clark, or makes up this person object that has the unique data of Tim Clark. So we can do age, we can do height, and then if we wanted to add something like favorite books, we can add a favorite books. Now, you could do something like this where you separate values with commas, but what would happen is that when you get this back in JavaScript, this is going to be seen as just a regular string, and you're going to have to do some kind of magic to parse that out. That would be painful if all lists had to be passed back as strings. That is, if we were limited to only strings and numbers as the values inside of our JSON. Well, it's a good thing we don't. We can pass array literals. So here, just like when we created an array, when we learned about arrays, we can use our square bracket array literal syntax to add an array of values or a list of values in our JSON format back to whoever asks for this information. And we do that simply by adding items to our array literals. So here, let's go ahead and do the Wheel of Time series. Really like that one. We can do, let's see, I'm probably supposed to put that inside of course, double quotes. Let's do Ender's Game, and we can do Helldivers, and a whole bunch of others, but we'll stick with those right now. So the Wheel of Time series, Ender's Game, Helldivers. Oh, we got to add the Historian. That's a really good one. All right. So now, not only do we have plain values using strings and integers, we now also have ourselves an array or a list of items. Now, when this JSON gets passed back to a JavaScript program, and this all gets read in, what we will end up with is an object just like this one, but it will have these additional properties in it. And one of them will be an actual array that we can access and index inside of our JavaScript, which means we could do something like this if we were in JavaScript. You're going to see error messages because right now you'll notice I am in a .json file, not a .js file. So it's going to yell at me right here, but I just want to show you the syntax. So it would be, once we got this back from JavaScript, or we got this back from a web service, we would have to do let person Tim equal, and then this is where I'm going to go ahead and say data we got back from web service is parsed and stuck in this variable. So hopefully you guys know what I mean. This variable points to a data space, a bucket, if you will, that we chuck data in. We would have some kind of code right here where we would be getting back information from the web service, and then we would parse it using the JSON parser, and then that would become an actual object in our program, and we would be referencing it by person Tim. And then we could actually index this array just like we would in an array in JavaScript that is attached to an object. We can go ahead and do the exact same thing. We can say person Tim, and then we can say dot favorite books, and then we can go ahead and index 0. And of course, if we printed that out, what we would get is the wheel of time, right? Series, right? So that would be the syntax if we were in JavaScript. Right now we're in a JSON file. All right. So now not only can we provide string properties and number properties and arrays or lists of things in our properties, we can also provide other objects as embedded objects inside of our object. So let's say that Tim Clark also has some other data about him that is an object itself with its own properties and information that makes it unique. So what would be a good object that would belong to me? Maybe I have a dog, and that dog, we're going to go ahead and record some information about that dog. So let's do breed. And my dog is actually an Akita. It's an American Akita, actually. And then within that breed, the type of American Akita is going to be a bear head. He looks just like a bear. And then we can talk about his weight. He is about 115 pounds. And let's just store that information. Oh, we need his name. Can't forget his name. Right, his name is Kiyoshi. Oops, I actually put the value of name as my property. So Kiyoshi. All right, so here we can see we've got ourselves a data structure that is an array that we can pass as an actual value to the favorite books property. But we also can pass an object, literal, or a hash map, right? And have it assigned to a property on our object. So we can pass all kinds of different data as long as it is structured just like we would if we were creating literal objects inside of JavaScript itself. And as long as we're following JavaScript's notation, and the only difference here is that for property names, we're also wrapping them as strings when we are creating JSON data, whereas when we are creating actual objects, hash maps, or anything like that, our properties follow JavaScript variable naming formats. That's the only real difference. So this is the kind of data we'll be getting back from web APIs that we make calls to in our assignments that are coming up. Let's go ahead and look at a sample of data coming back from a JavaScript API that pulls back JSON data. And in this case, we are pulling back weather data for our current location here from the openweathermap.org API. And here we're getting back some data for these coordinates. Actually, I don't think this is our current location. I think this might be London, England. But anyways, here you can see that we have this root object right here, and the root object has 12 properties inside of it. And here are the 12 properties. Here we've got a property that is a string, and then we've got properties that are just numerical values and other strings. But we can also see that this particular data that we got back from this weather API, we can see that some of these properties hold object literals in them. Here it's the coordinates, which ends up being the latitude and longitude. And then we've got one that has an array. Unlike our examples that we had before, instead of the array just containing primitive types, which would just be strings like we have here in this example, here we've got an array of objects, and we've got one object in that array, which means this object sits at index 0, but it is a full-blown object. So if I wanted to get to this, it would be object.weather and then square bracket notation with an index of 0, and that would get me to this object in the hierarchy. So let's kind of do that really quick. Let's see how we might do that. And we'll just pull up a new text file. And let's kind of write the JavaScript that would get us through this object hierarchy, just so we understand. So this is the data. If we called this URL, this is what would be returned to us by the web service. Of course, if we were in JavaScript, we would need to make sure that we went ahead and grabbed a reference. Let's go ahead and save this really quick so we know that it is JavaScript. So we'll do test.js. All right. Now we know it's JavaScript. All right, so let's do let. And then this is the weather data. So we'll just call it weather data that we got back. And then it would be this object, and it came from openweathermap.org. Okay. And it would be this whole object right here, this massive thing. So I'm going to go ahead and copy it really quick, and I'm going to put it in as my data right here. And of course, this would all be coming from a web service, right? And then we would get that data. Now, if you notice, just like when we were describing JSON, this is improper format from objects because all of our properties are inside of, well, we can do that with quotes in JavaScript. So we're still good even using quotes around our property names in our objects. But I'm going to go ahead and kind of indent this a little bit just so we know where things are at. Put our semicolon. So just pretend like all of this came back from a call to this web service right here. Now let's talk about how we get through JSON data. How do we traverse this data structure? Because really, it's one big object that's full of other arrays, values, and other objects, as we see right here. And really, all we're going to use is our JavaScript dot notation, like we've used a ton of times throughout all of these videos as we've been learning JavaScript. So knowing that our object is called weather data, let's go ahead and let's walk through how we traverse this data structure. So let's say that we are trying to pull out of our weather data the visibility level. Let's go ahead and do that. So we would go ahead and say let visibility equal, and then we know that we're storing all of this data that came back from the web service in this weather data variable. So let's do weather data. And then because visibility is a property directly on our root object, all we have to do is dot visibility, right? Let's try to do one a little more complex. Let's do the weather. Let's get to our first weather object and let's get the description. Let's say we want to pull that out. So let's do let's do weather description. Now, how do we get to that? Well, we do our weather data, because that's the root object that we have right here. We know we want to go to the weather property of the root object, because we can see that it is a property of the root object. So then we do dot weather. Now, inside of weather, we actually have an array, and that array has one object in it. So really, since this is an array, we want to get to the first object in that array, which is the only one. So we're going to go ahead and use our array indexing syntax, which will get us to this object. Once we have that object, Then we're going to go ahead and we're going to ask for the description property of that object. So we can just go ahead and dot description. All right, so let's talk about this one really quick, just to make sure we're crystal clear on this, because a lot of people have a hard time with what just happened here, because we are getting to a property, we're indexing, and then we're immediately calling for a property, but we're in an array. What's happening? A lot of people get confused by that. So we're going to jump over here to our diagramming so we can draw on top of this, and let's show how we're doing this. So we've got ourselves a weather object right here. And then we have, well, we've got our weather data object. Then we've got ourselves inside of the weather data object. Here, let's make that one bigger. We've got our weather data object. Inside of our weather data object, we have a weather property. And that weather property contains an array. And that array actually contains one item, which is just an object itself. All right, so now let's point to how this works. So weather data, when we call this particular variable, which we know is a variable, what we're really saying is, hey, JavaScript, go locate this object and then give us it back. And it gives us that object back right here before the dot. And then the dot says, hey, inside of this object that we got back, go find me an object called weather. So it goes into the object that came back just before the dot, and the dot tells it to go look inside that object and find a property called weather. So it finds the weather object, which just happens to be an array, and it returns that weather object right back here, just before the square brackets. So we've got this object sitting right here. Now the square brackets are actually being invoked on the object that we got back when we called weather. And now the square bracket says, hey, we know that the object that is inside of weather, we know it's an array, so go inside of that array and find me the item that is at 0. So it goes in, it looks inside of the weather array, and it identifies the first object in it. Right now it's our only object, which puts it at 0 index. And then it returns that object right here just before the period. Then we run into the period, and the period says, hey, go inside of the object and let's find the property. And so in here, how many properties have we got? 1, 2, 3, 4. We got 4 properties. So we got a property here, we got a property here, we got a property here, and we got a property here, right? So we got 4 of them. And one of those is the description property. So we'll go ahead and say description, and it's right here. And that's a bright, bright yellow. Let's change it to a different color so we can actually see it. We'll do description. That's right here. All right. So the dot says, hey, go inside of that object. So it's actually sending us back into the object. And it says, hey, go locate me inside of this object that's at index 0. And locate a property called description, which is this one right here, and then bring it back. And so the value that is stored inside of description, which of course is this value right here in memory, is going to be returned right here. And of course, the value goes right here, and we get a reference to it through this particular variable right here, and now we have a weather description. So you can see that this value right here, through all of this chaining, ends up inside of our variable for our use. And it all comes from the end of that call chain right there. Now make sure you understand how that all worked. I think we've been through it a couple of times now. It should be making sense. If it doesn't make sense, please make sure you go talk to the instructor or a tutor, or watch this video several times till you understand how this call chaining works. Because in reality, all we're doing is chaining different calls in order to reduce the amount of code that we have to write. Because we could actually create a new variable for each of these calls and end up seeing how that might come out to be like 5 or 6 lines of code, whereas this chaining allows us to go down through a chain of objects to get to what we want to and return just it instead of having a whole bunch of additional variable references. All right, so enough of that. Now we see how we can get into that data. So now let's do one really quick that just shows how we get into an object. So let's see how we traverse through an object to get to main, to get to today's current temperature. So let's do let current temp equal, of course we are pulling from the weather data object. So this call right here brings us back this entire object. And within that object, we want to find the property main. So we're going to say dot notation. Oops. We're going to do, I think I had that highlighted. We're going to do dot notation, which says, hey, go look inside of that object and find me a property. And the property we want it to find is main. So let's go ahead and do main. And then main, we know is an object just because we are looking at this structure. So we know we can just hit dot notation again. And then we want to get the property within this object, which is temp. So main brought us back this particular object right here, which is inside of that object. We hit the dot notation. We want to pull out the property temp. So dot temp. And then if we follow that again, weather brings us back this object, main. Let's point those out really quick just to make it super duper clear. Weather, when we make that call, brings us back this full object, the whole thing. So I'm going to point to the curly braces that wrap around it. Dot says, hey, go look inside of the object that we got returned back and look for the property main. And we know that main brings us back this object, so the entire object from this curly brace to this curly brace. So I'm going to go ahead and identify that first curly brace. Then we see the dot notation, which just says, hey, go look inside of the object we got back. And let's find the property temp, and it's going to come back and pull the value that's held inside of the property temp, which is going to be the 300.15, which that value comes back at the end of here and it gets stored in temp, which means reality, this value ends up being stored in temp. All right, hopefully that's not at all confusing. If it is, again, make sure you talk to your teacher or to a tutor. So here's JSON syntax. This is how it works when we're trying to access plain values, embedded objects, embedded arrays, and we can traverse throughout our JSON structure as many times as we need to, which means if we have within wind, or let's go back to our weather. So if we have within weather another array, we can go into that array. And then we can go into objects, and if those objects have arrays in them, then we can keep traversing through that data structure just using our dot notation and our indexing notation if it's an array. Now we can go as deep as we want as long as we understand the structure of our JSON objects. And that's really all there is to it when it comes to JSON.